Would like to take this opportunity to thank everybody joining us today. Can you just let me know if the audio is working? Oh, hi, El Ray. How are you today? Thank you for being here. Hi, everybody. Before we start, always like to ask, where are you from? Where are you guys located? Oh, okay. We have some friends from Portugal. Bienvenido. Hi, Vin. How are you? Okay. From Poland, Belgium, Argentina, here in the US in Houston. I hope everybody's doing well, staying safe, respecting whatever uh, mandates are in your country. That way we don't spread it. Oh, Vin from Puerto Rico. Excellent, Vin. I'm from the University, Polytechnic University down in Atorrey. That's where I graduated. That's where I'm from as well. I'm from Puerto Rico as well. So glad to have a partner here from the island. We have some friends from Canada, Mexico, and from Canada, Aaron from Canada, Alex, Israel. Oh, wow, nice. Thank you for being here. Gavin over from Taiwan, and some other friends from Canada. Thank you so much for being here. Colombia is in the house. Slovakia. Wow, George, we got a really nice spread going on today.
Hmm.
Well, my name is Edwin Robledo. I'm part of the kind of the tech marketing and support team for Fusion 360. So we'd like to welcome you joining us. Today it's going to be talking a little bit about electromechanical workflows. We'll do our best to do it as short as possible, but we really want to go into certain details that we really feel that are worth to mention. So I'll be sharing my screen and showing a little bit of Fusion and some of the workflows that we currently have. So thank you so much, Netherlands. And oh, excellent, Vin. Glad to hear. I hope it's working out for you. Shortly after I graduated there, I moved to the mainland. Um, Slightly. I don't want to. I don't want to say what year Jorge I graduated because it's gonna show my age. So I think I'm just gonna hide that one. That's awesome. Well, we got a really nice spread from all over the place. You are correct. I don't know if I did. Did I mention Portugal? Yeah, Portugal is not in Spain. I mean, they're right next to each other, but it's not part of. It's not Spain at all. Arizona. Thanks for being here. Got a nice presence from Hawaii. I mean, I'm sorry, from Canada. Thank you and welcome from being here. I hope everybody's staying safe and everybody is well, and that all your loved ones are doing well as well. Oh, hi, Owen. Thank you for joining us. Glad you're able to join us again. Sorry about that. We did have a little bit of a kind of a difficulty in the beginning, but we were able to sort everything out. So, my name is Edwin Robledo. I'm part of the Fusion 360, primarily with electronics, and also I provide support for Autodesk Eagle as well. With me today, we have Jorge Garcia. He'll be doing some presentations as well today. Jorge Garcia, you'll see him has a strong presence on the Fusion 360 electronics as well as in the Autodesk Eagle as well. If you are submitting cases for any type of workflows or anything that you're encountering, there's a good chance that you'll be seeing Jorge, Rick, or myself taking care of those. I was hoping that Rick was able to make it, but he's out of Germany, so this is kind of really late for him to be joining us. So let me just go ahead and move over, and let's go ahead and start our demonstration today. So one of the biggest challenges there's always been working in any type of consumer product or personal projects is the fact that is the fact that you need to share files between both hardware engineers. I'm primarily referencing to the circuit board designer and the mechanical designer. Mechanical guy, as all of you already know and experts, you're creating the enclosure, where it's going to be, where it's going to fit. But you like to verify this information by the electronic engineer to provide you some sort of a file. That way you could virtually make sure it fits. So you need to be converting files like DXF, step files, or some other files as well. Now, with Fusion 360, we've been able to be able to capture geometries within the mechanical realm and transfer that data over to the circuit board editor without any need of having to use any type of file conversions. And I'm going to show you this example that I have here really quick. That way you could see, and in this workflow, I'm primarily using the fact that the PCB, the enclosure, is actually leading the circuit board design shape. That's what I'm doing here. So I'm primarily doing that workflow. So here I'm going to be capturing the enclosure and take that over to my circuit board. So how that process usually begins? Well, let's say this is just your standard enclosure. I actually tried to create something with kind of with a couple of odd corners, because to be able to draw this in the circuit board 2D PCB wouldn't be as easy, even though we do have implemented splines. But how do we transfer this data to be exactly what we need from the enclosure over to the circuit board? It's best to be as accurate as possible. So the process would start the following way with using Fusion 360. I'll go ahead and select that I want to create a sketch. Now, the first thing that is always going to be asked when you generate a sketch is on what plane you want to draw it on. Since I want to actually have the circuit board sit on the standoff, I'm going to select this plane right here. Okay. With that selected, I'm going to go ahead and click on Finish Sketch. Primarily, that's where I want. I just wanted to set up the plane. Okay. Now, with the plane selected, I'm going to go ahead and click Create PCB.
Hey Ed.
Yeah.
Something happened on YouTube. Let me see. Okay, no, it's okay. I stand corrected. But I said it was just behind or something. Continue.
Okay. Very well, George. Thank you. Okay, so now I click on Create PCB. Now I'm going to select the profiles that I'm going to actually be using for my PCB. I'm going to select this profile that we have here. It's going to be going on this plane. But I don't want the entire standoff to come through. I only want the small part of the standoff. So let me just go ahead and select these portions here. One second. Let's go ahead and cancel this out. I want to project this bottom here. This is the projection I want to do. Now that I've projected my sketch, which is basically the entire bottom that we have here, I'm going to go ahead and select the offset option. And I just want to make a little kind of a 1 millimeter offset, because I don't want the circuit board to go all the way to the edge. So I'm going to change this to 0.5 millimeters. Okay, because I didn't want the circuit board to like be butting against the enclosure right there. So that's my projected sketch. I'll finish the sketch for now, and then now I'll go ahead and click on Create PCB. Now I'm going to select the profiles that I actually want to project for my PCB. I select that one there, and I want to select these. I only want the outline of the hole of the standoff. I had to change resolutions because it was not allowing me. It was a little easier when I was using a little bit of a higher resolution. So selecting the entire body, which I don't want. I only want to select. So let me go ahead and try this one more time. Let me edit my sketch. And then let's go ahead and project one more time. That way I only project these bodies here that I want. I only want these outlines. That's what I want projected as well. You know, George, we always, you practice this many times, and when you go live, it's just the way what happens. Okay.
You're saying to click and keep the button down until the submenu appears, where you select the profile you want.
Okay, perfect. Will do. Okay. There it is. So here's our circuit board. As you could see, what happened is I went from the profile, or after capturing the profile and creating the 3D PCB, it created what's called a 3D PCB. Okay. So now we have the circuit board, and you could see that that it automatically adopted the contours that I had on that circuit board. To draw this on the 2D PCB would be a little bit of a challenge. Therefore, by just projecting the outline, so this makes it a lot much easier. Let me just go ahead and say what we have so far. Okay, I'm going to be using this on my circuit board. So let me go ahead and create a brand new electronic design. I start always with an electronic document. As you can see, you always start with a brand new electronic document. And the electronic document, the importance of the electronic document is that it's going to tie everything together. That's what keeps the circuit board, the schematic, and the 3D PCB all kind of working together. So from here, I'll go ahead and save what I've done so far. It adopts a name, electronic design. I'll create a brand new schematic. Okay, and I'm just going to add a couple here to the schematic. Nothing fancy. It's going to add parts, no connections, just for time's sake. Go ahead and create a circuit board now. Notice I just created the schematic. I'm going to now move over to the circuit board. You notice that by default, we get a board outline. We get this board outline, and all my components appear on the left-hand side of the circuit board. I can just start grabbing these and putting them inside the circuit board. This board outline that we have here. And I'm going to right-click one of them. I'm going to right-click the largest one, and I'm going to mirror it. Mirror it means that it's just on the bottom side of the board. That's all it means. So we have the two resistors on the top and one component on the bottom. That's all we have so far. Now I want to use the outline that the mechanical engineer actually was using, that he used for the projection. How we would accomplish that. Let me save what we've done so far. I like saving from the electronic document. You don't have to do it from there, but I just like saving from the electronic document because it kind of cascades it all completely over. As you can see, all the dirty files become clean files. Now what we want to do is that we want the circuit board to actually be using the outline that we created from the projected enclosure. So I'll go here. Now I'm going to link this. I'm going to click on link to PCB. I'll select the PCB that we created, which is this one right here. As you can see, it's this one right there. It's that one right there. Now I want to link this one right there, and I'll click on select. Okay. Now you notice it was that easy. I didn't have to do any type of file conversions. I'm getting those hatch marks there because I got a DRC error. I'm just too close to the board outline, so it's just letting me know. Okay. Now let's go ahead and we want the 3D PCB to synchronize with the 2D PCB, which actually has components in it. As you can see, in the 2D PCB, they put up these holes and line them up correctly with the enclosure. The mechanical engineer would have to be giving me those coordinates or giving me some sort of a file. That way I could import that and get the location of those holes. With this method, I just projected everything and then I came over here and they were there already. So let's go ahead and move this over to the 3D PCB. Have this icon here, it says View 3D PCB. When we do this, what's going to happen is that now the 2D PCB is going to send all of the information to the 3D PCB, and it's actually going to catch up for us. As you can see, I have the two components on the bottom side, which are the two that I have here. As you can see, they're in blue. I have two of them in blue. Okay. And I have one in red, which is the one here on the top. Okay. Let's go ahead and save it, what we've done so far. Now, the question that we've gotten often, Jorge, is like, how do I insert this into my enclosure now? It's something we want to improve on, and we will be improving. It's already being worked on, but I will show you the method that we currently have. Okay, so let me go to the enclosure that we currently have, this one right here. Save what we've done so far. I'll turn off all the sketch. I don't need the sketches anymore. I don't need the sketch profiles any longer. Now what I'm going to do is the 3D PCB, which is this one that we're working on right here, I'm just going to right click it and say that I want to insert it here. As you can see, it doesn't line it up so well. This is something that we're currently working on. So let's go ahead and rotate it. 90 degrees in that direction. Go ahead and rotate it 90 degrees in this direction. Okay. And then I'll click OK. And I'm just going to use the joint function. Hopefully I can get it right this time. I'm going to select right here, the center of this hole right there. And center it right here. Okay. And click OK. As you can see, I was able to fit my enclosure. Pretty straightforward to fit my enclosure there. Now, the question that we've gotten in the past is like, so how do I move components that way they reflect on the enclosure? For now, within the design realm, we're not in the design workspace. We're not able to move components here yet. That's something that is currently being worked on, but you can move components in the 3D PCB and they will actually reflect on both ends. So I'm just going to take this component here. Actually, I'm going to go ahead and separate my screens. That way you can see this in real time. Okay. So I have the resistor one, as you see here, which is right here as well. Okay. Now I'm going to go ahead and I'm going to move. Let me make this screen a little bit smaller. Let me shrink it a little bit more. That went on. So I'm in the 3D PCB. I'll go ahead and click on here on move, and I'll select this component and I'll move it. Click OK. And actually, what I'm going to do is I'm going to take this IC that's on the bottom. I'll select this and I'll flip it over to the top. You see we have that mirror option there. Flip it. I'm going to put that on the top here, and I'll go ahead and click OK. Now I want to synchronize between the board and the schematic. You'll notice that the R1 is actually going to move, and the IC1 is actually going to be switching layers. Let's go ahead and do that synchronization. So I'm going to push the 2D PCB. As you could see, the component move. It's pretty fast the way it works. Now we need to push back to complete the cycle, or to complete the synchronization. We need to push it back to the 2D PCB, to the 3D PCB. I'm sorry. So I click here. Okay. Okay. As you could see, it actually updated. So now everything is synchronized. So I have my IC and my resistor on the top, which I flip to the top, and I have my other component. The R2 is now on the bottom all by itself. Okay. Now what happens on my enclosure? Let's take a look. Let's say what we've done so far. And let's make sure that the enclosure is actually catching up. You'll notice that the enclosure is actually dirty. You see that little asterisk right next to the name? It's just letting you know that it's not saved. I'll give it a minute. Let's go ahead and save so far. Okay. I'm waiting for the, are we getting a synchronization notification right here, letting me know that there's been some updates on the 3D PCB that need to catch up. I did this like 10 times today. It was working pretty good. So let me save here. See. Okay. Well, I gotta find out why is it not working.
Hey Ed, Aaron is saying that maybe the out of date icon is being hidden because the window's too small. So the tiny chain icon with the yellow triangle. That's the one you're looking for,
Yeah.
right?
Yeah, yeah. When I did it earlier today, it actually did come up. So not sure what's broken. That it's not catching up with it. Not sure what happened.
Make sure you have everything saved, which it looks like you do.
Yeah, everything is saved. Everything should be looking good. So not sure exactly. Everything is linked. Everything is properly linked. So let's try one more time. So let me break this link. Thank you, Aaron, for being here. Appreciate it. I hope everything is doing well. Um, So anyway, the idea would be to that once you actually catch up, it would actually just kind of like it would show up here. Let me try it one more time. It's kind of strange because I did this many times today before the presentation, and it was actually working pretty well. So let's go ahead and say what I've done so far. Okay, insert into current design. Okay. 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 So it's actually catching up the 2D. I moved them one more time. I got to go to the 2D PCB. Let's try this one more time. There it is. Okay. This is what I wanted to show you right there. So any modifications that you actually do to the 3D PCB and you push them over to the Fusion 360 design workspace, any modifications will actually come up, alerting you that there's been modifications that need to be synchronized. So I'll just click here and it will actually now update the circuit board, which is this property right here, this body that we have right here. It will actually disappear, letting me know that that's synchronized. Okay. So that's as much as I wanted to demonstrate today. I'll go ahead and stop sharing my screen. That way, Jorge, I had one more I wanted to show, but since this one took me so long, I'd rather just move on to the next demonstration. So give me 1 second. I will stop sharing, and Jorge, you can go ahead and share your screen.
Okay. So Ed, if you want to take the chat, we have a question of when are we going to do a stream about libraries? I know you have a whole bunch scheduled, so I figure one of them is there. One of them is library.
Yeah, one of them is there. We're doing one for Eagle. I think it's for next week. So consider taking a look at that. I will be doing another one for it is on the list of webinars. I think it's in a week and a half. So not the following week. The following week, I think we're doing libraries. I think next week we're doing simulation, and then we're doing libraries.
Okay.
So I don't see your screen yet, Jorge.
All right. Let's see. Okay. Sharing screen now. I mean, if you can see it.
Yeah, we see it just fine, Jorge.
Okay. So the idea here, and this is basically going to be a recap of the video that Matt did showing the insert derive workflow. So this is basically, excuse me. This is basically how we are recommending that you do PCB driven workflows with. So right here we have a PCB design that's already done. I'm going to go ahead and click View 3D PCB. And here's the 3D PCB for this board. It has most of the models assigned. In fact, it has all of them. Memory serves. Whoops.
Just for those music fans, this is a guitar. This is a pedal.
Okay, so everything is assigned. And what we're going to do is we're going to use this to kind of drive the enclosure. Okay, so what I'm going to do is I'm going to go ahead and create a new file. And what we're really going to try to do is just kind of work out the outline first. Okay, so I'm going to go over here to New Design. I'm going to save it. Because we're going to use the insert derive workflow. Save. Okay. So now I'm going to go to the insert menu and select insert derive. So what this lets you do is it lets you bring in sketches, bodies, geometry, etc. from another design and use it as reference material in this one. So I'm going to click insert derive. I'm going to select this file, which is the one I want to derive from. Hit select. And what's going to happen is it's going to take me over to this file. It's going to ask me, what do I want to derive? Okay, so I can clear the selection completely. I'm mostly interested in the sketches. So I'm going to go into sketches. I'm going to say the outline. And that's really all I want. Okay, so I'm going to click OK. Once I do that, when we go, it's going to take me right back to the file. And the sketch is not visible right now, but it should be here. And you'll see that it's been brought in. Okay, it's derived. Now at this point, what I can do is I can use this as the basis for driving an enclosure. Now let's say I was going to make a really tight enclosure. What I could do is I can go ahead and draw a new sketch. Okay, I'm going to draw on that plane. What I'm going to do is I'm going to go ahead and project this one. Actually, what I should do is, let me escape this real quick and delete this. I need to put in a plane first. Delete, okay. So what we'll do is construct offset plane from here, and I want it to be 3 millimeters. Let's do 3. Okay, and now onto this plane, I want to just project the main outline and the 4 mounting holes. So what we'll do is I'll go create a sketch. I want it there. And then what I'm going to do is I'm going to project. And the things I want to project are just this one, this hole here, this one. Nope, not that. That. There we go. There we go. Let's take off anything that I don't need just to be safe.
I just want to bring up the fact that what Jorge is doing now is when the circuit board is actually going to lead the size of the enclosure. We got a lot of new people came in, Jorge. That's why I want to bring it up.
Okay. All right, so this is everything I want to project. Divide entities, projection link, say okay. Good. So now what we want to do is from that, I'm going to finish that one. Actually, no, I wanted to make a further edit to it. Edit sketch. What I'm going to do is I'm going to draw an offset. Curves. Did I get it? Yes, I did. Okay. And I want to give it 2 millimeters just to give some good room. Nope, not 200, 2. Okay, perfect. So now we formed the sketch, 2 millimeters. And what we're going to do is I'm going to go ahead and shell this. Okay. So I'm going to finish sketch here. I'm going to go ahead and go to extrude. Yeah, I'm just going to do the extrude first. I want to select that profile. Okay. And I'm going to go ahead and pick, let's say, 10 millimeters to one side. Say okay. Now from here, one thing that we want to kind of emphasize is this is linked because of the insert derive workflow to the PCB, to the 3D PCB, and to the original 2D PCB. So if I make a change here and I save it, you're going to see it go downstream. Okay, and that's really the key part that we want to highlight with this workflow. Is there a question, Ed? Somebody put something up?
No, we're good.
We're
Yeah,
good.
some of the guys are talking among themselves there.
Oh, okay. Yeah, if they got tips, I'm all ears. So,
So I'll let you know.
all right, cool. So what I'm going to do is I'm going to go ahead and make a change. I'm going to save this one first before we continue. So let me bring this.
Yeah, maybe you could just close the data panel. That way we get a little bit more what you're working on.
Okay. There we go. Okay. And now I'm going to go over here to the PCB. I'm just going to make a big change. Just something ridiculous. Old habits die hard. All right.
I know. Always trusted command line.
Let me do something different. Something with the miter. That way it's not so. Okay. So we can all tell that I've made a very drastic change there. Okay. So I'm going to say okay to that. I'm not going to save it. Always good to write changes. Okay, let me sync it first. Okay, so now it syncs. You'll see the big curve show up over here. Give it a second. Still going. There it is. Okay, so now I can go over here to this, to the 2D PCB. I can save it. Okay, it'll be saved. Now this one should be saved as
There's
well.
the change it took.
Yep.
Yeah.
And now if we go to this one.
Yeah, we could see the change there, Jorge, as well.
You guys see get all latest. So now if I click here, you'll see that this propagates the whole way through. And now I have yellow, which I know is not good. How do you fix the yellow, Ed? Because I got this one here. The derive came in correctly, but now the sketch didn't update. It says it's locked here. Wonder what happened there. See, because it came, and the derive it came, but then this downhill sketch didn't. Redefine sketch plane. Ah, that's why. No, it's not that. Okay. So cancel that. Review warning. Project source is lost. So I guess because I use it as a projection.
Jorge, yes, to let you know, can you hear me?
Yeah, I can hear you.
Jorge, yeah, so apparently the platform that we're using to broadcast,
Yeah.
it cut off entirely. It shut down and it came right back up.
Okay.
So YouTube is catching up shortly, okay?
Okay. So do you know how to fix this yellow? Because this went yellow and
you're gonna have to share your screen one more time because we've lost your screen.
okay. So let's see. Can you see it?
It came back. Yes, it did.
Okay. So I guess the fact that I changed this curve and I had done it as a projection, a linked projection, it didn't like it. What I should have done is maybe just built around the derived model. But I mean, either way, I can edit the sketch. Okay. So let me just okay, and I'll just do another project. Okay. And then what we can do is that'll be the sketch that we want to use for the extrude. So if I say finish sketch, does it change anything? No. It does not. Oh, because I have to redo this part of it too. That's why. So note to self, projection is not the best way to go for this. Probably not doing this in the best way possible, but okay, 2. There. Now if I say finish sketch and I take it to the other side, yep, same issue. So basically the way I did it was not the best way.
Yeah, delete.
Okay, it was supposed to automatically update, but I guess the way I defined the sketch and profile was not the best. Okay, but that would be the basic idea. It basically allows the changes to transfer across to the enclosure part over here. And as you make changes, assuming you don't do them with projection profiles like I did, everything would keep track. Do we have any questions or any suggestions, Ed, on the YouTube?
No, not yet. But there's one more. There was just one more fact that I wanted to just show really quick.
Go for it.
Let me go ahead and load this really quick. Was the fact that if you move patterns, or if you move components in the 3D PCB, it actually takes effect live um, with the 3D as well. So let me show that really quick. Let me link these up really quick.
Mm-hmm.
When it comes to my internet performance, I don't know why, but it's not going as fast as I would want it to.
It's all right.
Now, there's before we actually go to show moving parts, it's come up often enough that users want to take a projected a PCB in the 3D PCB. They'll like to make modifications in the 3D PCB. They'll actually like to see the changes. They'll like to make those changes here. And there's a couple steps to do that. So let me show that to you really quick. It's loading. Give me one moment.
Yep.
Okay, so if you've created a projection, created a 3D PCB, and you have an outline, but you need to make modifications to that outline, the way you would do it in the 3D PCB realm is, and now you show you, just make sure that we have synchronization between our 2D and our 3D. As we see here, we have, it's exactly the same. So I'll make just a small change here. So I'll do a right click where it says the outline down in the, right there. I'll just do a right click and select edit sketch. As you can see, there's my sketch, and let's just do a real subtle change, such as let's
Ed,
just fillet.
I don't know what you're transmitting, but you're transmitting the YouTube page right now. That's what you have on shared.
Okay. Okay.
Okay, yeah, this looks right.
Okay. So I'm going to cancel what I've done so far because that means that they didn't see, you were not able to see what I had done earlier. So let's do this real quick. So I'll set this up again. What we're trying to do here is we want to make modifications to the outline of the circuit board in the 3D PCB realm. And the way you do that is that in the 3D PCB editor, I'll just right click and select the option sketch, as you can see here. Now I could see the outline. Let's go ahead and do some fillets and fillet this corner here that we have here. And let's just make it very subtle. We'll do it at maybe 2. Just make a very subtle change. As you can see, it was square there. And I'll do the same one over here. And I'll set it to 2 as well. So I just made some modifications there, and I'll click on Finish Sketch. Now, there's one more step you need to do. I'm just letting it catch up, because if you'll notice now that the board outline is going to come up square again. It hasn't adopted my corners yet, so you can see it right there. So I'll just do a right click on the extrusion, and I'll select Edit Board. Okay. And now I'll click OK. Once I select the profile, once it refreshes, now it'll have the new board outline that we have as well. Now we'll go ahead and synchronize the 2D PCB. And you notice that now my corners, the only reason you're seeing that extra copper is because that's of the polygon. The polygon is out there, so let me just delete that polygon. Delete. I'll just delete this polygon really quick here. Let's get rid of it there and here as well. So as you could see, the modification that I did in the 3D PCB actually modified on the 2D PCB within a matter of minutes. No file conversions necessary. Let me go ahead and save. There's one more instance I want to, one more chain, fillet, bottom corners. I'm going to go ahead and split my screen one more time. That way, this change that I'm going to do now, I'd like you for to contemplate it live. So let me just go ahead and split my screens one more time. So what I'm going to do now is I'm just going to move some parts here. And there's an option that I want you to see as mechanical engineers, which I would say that many of you are, is I'm just going to move this component right that we have here. I'll just move this one here that we have here. I'll zoom in on it a bit, which is C43, which is this part right here. This part right here, the C43. So I'll click here. I'm sorry, no, I don't want to flip it. I just want to move it. And let's say we move this down. Let's move it down and maybe a little to the right. Please notice that there's this option here. It says update PCB right here. So let's go ahead and click. It's loading. Sorry about that. It's just loading. Please notice that when I select the asset, which in this case is a component, you have the option of rerouting, as you could see here. What that's going to do is that it's going to try to fix all this routing that we have here. It's going to actually try to reroute it. So I'll select that option that we have there, and I'll just move the component. Just move it down a little bit and over. Let's move it to the edge of the board, even though it's some DRC violation. So let me just move it back a little bit. Let's move it and click OK. Now what's going to happen is that it's going to move the component in the 2D PCB. In the 2D PCB, it's going to actually perform the rerouting, and it's going to come back to the 3D PCB and give me those results, all with the, only with one click. So there was no need for me to push and to have to push and pull between them. As you could see, it rerouted it in the 2D PCB, and it routed it here as well. So you get the results in real time. Therefore, I actually save several clicks there without having to go back and forth the way they would synchronize. Thank you, everybody, for joining us. If you have any questions, please join us on the Fusion 360 Electronics forum page, which are very active. But this is, in essence, we wanted to show you how is that you capture an enclosure and select that profile to be your PCB in 3D as well as in your 2D. And also, how is that you could create an enclosure for a PCB and it will make the changes. And also, I wanted to show you how is that you can move components within the 2D and see the effects on between the 2D and the 3D, how that interaction works in real time. And yes, somebody did ask about supporting multi-monitors. Yeah, you just got to click and drag the tab, and that should be enough. Okay. Thank you for joining us. Everybody have a great day. It's been a pleasure, and please stay safe. Um, hopefully everything is going okay for everybody.
Bye, everyone. Thank you, Ed.
No, thank you, Jorge, for everything. I greatly appreciate it, man.
Bye, everyone.